All right, I will say good evening, although it's Sunday morning as I'm recording this video, and obviously this is a unusual and hopefully once in a lifetime scenario where we have to present a class under these circumstances. I will say that we are committed to getting through this last 8 weeks. The school has confirmed that this is going to be the mode of instruction at least through these 8 weeks, possibly even through the summer, with the expectation, I think, that in the fall everything should have returned to normal. So just a few preliminaries here before we really get rolling. I want to make sure that you're watching this, should be watching this on YouTube. And obviously I don't think you'd be watching it if you weren't, if you hadn't intended to watch it. It's not very entertaining. We will be working sort of in a multimedia mode here. I'm going to post written materials, at least class notes on Canvas. I think all of you know how to access those. They will be, for the most part, Word documents. Those documents, of course, you're free to download, save, and print. In conjunction with those notes, and those are the notes that I'm going to be talking through here today, we will present these videos. I'll try to put these up a little bit earlier as we go along here. Obviously I'm kind of feeling my way through this. So I would like you to watch the videos, read your notes, and then on Tuesday, since we are a once a week class, nominally scheduled for 5:30 on Tuesdays, each week I will set up a go-to-meeting conference call. For right now it's going to be strictly audio, strictly from your phone. As time goes by, I'll try to set up a video link so that it's a little more interactive, but we're going to try to baby step through this so that we don't have a lot of technical problems. I do know how to do the phone portion of it. Each week then I will send you a link through the email that will give you the phone number to call and an access code. The access code has to be keyed in with the # at the end, and that will connect you to the phone that I am at. Hopefully we'll be able to get all 12 or 13 participants on the call, and what I will do then is, to the extent possible, I will answer questions. I will review the notes in the videos and make sure that there aren't a lot of questions. I doubt very much that these calls are going to last the full nominal 2.5 hours. I don't know how we could really do that. I think all bets are off in terms of, you know, how many hours of instruction and all of that. In normal circumstances, I don't have any trouble filling those hours, especially since we only have 8 sessions. We do have to move right along. I am going to obviously sort of adjust my lesson plan to accommodate the circumstances. There's going to be certain concepts that are going to be skipped, I think, the little more advanced concepts, because they do require sort of a face-to-face question and answer period. So this session is for DRF 128, Geometric Dimensioning and Tolerancing. I see from my roster that at least some of you have had me for blueprint reading or metrology, so you know how I kind of roll. This is going to be very off-putting for me. I'm not used to sitting at a chair or in front of a camera, for that matter, trying to present this material. I move around a lot. I talk with the class members a lot, and not much of that is going to happen. The video is strictly amateur. It is just me here. I am going to be up and out of my chair periodically to shut off the camera and adjust it for when I go to the board. But for at least for most of this session, it will be me sitting in this chair. So obviously you're free to skip through the boring parts and take a break, do whatever you have to do to get through this. I think those of you who had blueprint reading and GD&T, you know, it's a technical topic. GD&T is a particularly technical topic. It is directly related to blueprint reading and to some extent to metrology. They all tie in, like most technical materials, they sort of interweave. But this one is not one that lends itself to a lot of hands-on. It's geometry. It's an offshoot of mathematics into the technical realm. So very early on, we're gonna step into some of the basic geometric concepts that you've probably heard already. If you've had geometry, even if you've had metrology and blueprint reading with me, I always talk about these concepts, these geometric concepts, because we don't think about them all the time. You know, for me, I had geometry in 1969, so even I have to refresh my memory about these concepts. But they're going to become extremely important as we try to get through this class. It is geometric dimensioning and tolerancing, and one of the first things we'll do is talk about why we even need something like geometric dimensioning and tolerancing. We've been obviously making drawings, making things for hundreds of years. The system that we have has evolved very well, I think, to meet most of the technical needs of manufacturing. But there are some weak spots, and there are some significant weak spots, and again, we'll talk about how those were uncovered and how this system evolved. Before I go much further, I do want to talk about the text. After many, many years of complaining and begging the school to get rid of the GD&T text, they have finally done it. It should be a significant improvement over the other text. The other text was very elementary, very poorly organized, and from my point of view, it did not teach GD&T in any way that I understand it, so I could not really use it. So it's gone, and in its place is the actual standard for geometric dimensioning and tolerancing. That text is ASME Y14.5. You'll hear me periodically, if I mention it, I'll often call it ANSI Y14.5 because that's what it was for many, many years while I was learning the system. And only recently, in the last 15 years or so, I would say ASME, the American Society of Manufacturing Engineers, Mechanical Engineers, picked it up and now maintains it as part of an enormous library that they maintain of technical standards. So the actual standard itself is fairly compact. I like it because of the way it's organized. It's organized in a fashion that builds on an understanding of the system. It's maybe a little bit more technical than we need for this class, but at the end of the class you will have the standard, and over the years as you actually work with this system, you'll have that to reference. Because ultimately, when push comes to shove, you run into a geometric dimensioning problem, either from a drawing or an inspection, you're going to have to figure it out. And heaven knows the textbook that was originally available was no use in that regard. I like the standard, again, for its organization. It is written in fairly dense technical prose. I'm going to try to sort that out and highlight critical areas of it. The system has evolved from a fairly simple and straightforward system over the last 30 years into a very detailed method of controlling very complex issues on manufactured parts. So anyway, the standard is kind of a tough read. I'll often say that I think the people who wrote it don't speak English as their native language. They use some terminology that's a little cumbersome, and I'll try to point that out and give you at least a real world equivalence to some of the terms they use. Okay, in terms of getting the text, I don't know how the bookstore works. I don't know if it's going to work for this session. I have posted on Canvas a paper that called Text for DRF 128. It lists two websites that you can go to. The one I recommend, since it appears to be the cheapest, unless you can find a used version of it. I had looked around, I could not find one on Amazon, at least in the current revision. So if you go to the ASME website, so it's asme.org, and key in Y14.5, it should link you directly to their store where you can buy the standard for $230. You'll have the option of buying a hard copy of the standard or the PDF. I can't recommend the PDF. One is, as I use the standard, I find myself flipping through, looking for the right illustration of the concept, and PDFs just don't lend themselves to that very well. The other thing is I think you're limited or even forbidden to print from that PDF. So I would buy the hard copy version. Either one of them is $230 from the ASME website. I think that should be a sight cheaper than what you're going to get from the bookstore. The other option is Amazon, of course. Amazon has it for $264.50. Now again, both of these sites have the current version. The previous version was the 2009 version. The 2018 is the current version. I will say that if you can find a used version of the 2009, that should get you through the purposes of this class, but again, it will be outdated. I don't see significant enough changes between the two standards that it will matter. I have both copies, so I can flip back and forth if you have a question, if you get the newer one. Again, totally up to you. I am going to clip out and explain the key aspects of that standard and post those on Canvas. You will want the standard again just for your own reference when I'm not here. In the next, after 8 weeks here, obviously I won't be here to answer any questions, so the text will be useful. So again, look that over. I really I think they're overpriced, obviously, but they have a monopoly on the market. There's really not much we can do about the pricing. Okay, the second topic is the syllabus. Now, again, this is a different world that we're living in, at least for the next few weeks here. So I've adjusted the syllabus a little bit to accommodate the new schedule. Right now, the syllabus lists this Tuesday as our first class date. They don't seem to have extended the semester, the same finals day, the same last class day is listed. Since this is only an 8-week class and we've already lost one week, I am going to try to jam one of those weeks over the next 7. And we should be able to do that just so that we can stay on schedule and take our final as needed. Obviously, the attendance and missing assignments business, I'm going to be very lax with this. I can't tell whether you've watched the video. I won't be able to tell from the conference calls very much. What I will be able to tell is how well you do on the tests. I am going to have the same tests I've always had. I will post those on Canvas, and how that's going to be handled is TBD yet. I don't know exactly how Canvas does tests. I always do a written test. I always have unlimited time, and I think at this point the only prohibition against cheating is on you, and I have to trust you to do your tests honestly and turn them in. I've always used a 10-point grading system, and that's posted right there in the syllabus. There will be 2 tests over the course of the 8 weeks. Sort of an initial test to get you in the mood, a second test, and then the final. The grading will be 30, 30, 40. Typically the first test is always the worst because it's just a new way of thinking, and you just have to sort of get into it. The second test is always better. I don't think that's ever been not true. And typically, even though you've done, not as well as you would like on the previous 2 tests, the finals usually do pretty well. So we'll just sort of feel our way into that. Now again, the school may come along and decide that this becomes a pass-fail class. A lot of schools are doing that just because of the disruption, and I can support that either way. But right now this is a graded course. I've listed 8 sessions on the syllabus. Obviously we're going to have to adjust all of that. The important part is I have scheduled tests for session number 3 or week 3, session number 6, and then the final. Again, we only have 7 of those, so again, things are going to have to move around a little bit. So I'm asking everybody to be flexible. If there's a problem, obviously I need to hear about it as soon as possible so I can adjust whatever I need to adjust. Okay, so the syllabus is also on Canvas. You'll be asked to download that and keep a copy of that. That is just a school policy, but again, don't take it to heart and don't think we're going to follow it exactly, because under the circumstances we really can't. All right, so I think it's now time to start GD&T in earnest. So I'm going to introduce myself again. My name is Mike Trepanitis. I'm a vice president at Novatech here in Lynchburg. Now, normally I would ask everybody, have you heard of Novatech? Do you know where we are? Won't do that this time because I can't see your hands raised. Novatech is a 30-year-old company. We've been in Lynchburg all this time since 1994, and we've specialized in advanced engineering, design and analysis, and we also do testing and prototypes and that sort of thing. We're located on Jefferson Ridge Parkway, which is by the Sheets on 221, not the one far out in Forest, but the one right next to Billy Craft Honda. So if you go down that road, Jefferson Ridge Parkway, just before you get to Frito-Lay, you'll run into Novatech on the left-hand side. So who knows, maybe we'll be able at some point, when they lift the constraints about people in a room, we can meet here for sessions, or ideally we'd meet back at CVCC. But again, CVCC has made it clear that they are not going to resume classroom instruction here for these 8 weeks. All right, so my background. I'm going to offer this background for a reason, but let me get through it. I've been in the technical fields my whole career. Since I was 17, I started out as a draftsman in high school, working night shifts, believe it or not, doing technical work and illustration, mostly in ink. I went into the service in 1973 in the Army Corps of Engineers, where I was a surveyor and a draftsman. engineering school from 1977 to 1981, and I've been a designer or a research engineer ever since. I've worked in the machine tool, aerospace, and nuclear industries. These are all very advanced industries. And ever since I was in the Army Corps of Engineers, I've been exposed to GD&T in a number of different forms. So I've watched it evolve into a fairly robust system. So again, I offer that just to tell you and to warn you, I guess, that I've taught this class for almost 30 years. I've used the system for almost 40 years. I am very familiar with it. It's very easy for me to go off assuming that you're following, and unless you pipe up, and to the extent that you can pipe up during the conference calls and ask questions, I won't know whether you're getting a concept or not. I've gotten the concepts. I'm presenting them as clearly as I can under the circumstances. You're going to have to tell me whether it's not clear enough or whether you need some, further discussion about these concepts. We are going to have to move along fairly quickly, but I will certainly stop and revisit any concept at any time to make sure that you're getting it. Okay, so what is GD&T and why do we need to have a separate class as opposed to a drafting class or a CAD class? As I said, the technical world has evolved to the point where we can create fairly consistent drawings, and we have a dimensioning and tolerancing scheme that has evolved right along with that. And the approach to doing this has been standardized for a long time. So no matter where you go in this country, and even around the world, the way drawings are presented is pretty standardized. Drawings look pretty much the same. Now in blueprint reading we talked about first angle versus third angle projection, and that's different. But once you get used to that, the pictures are the pictures, the dimensions are the dimensions, and the tolerances are the tolerances. And that carried us into the industrial age and right up to World War II. And at World War II, all of a sudden, for the first time ever really, manufacturers had to come together and produce the same thing from a multitude of different locations and have parts show up maybe at a third location and all fit together. And very quickly they realized that the dimensioning and tolerancing approaches that were in use at that time were inadequate to that goal of making sure that everybody did everything the same way. So during the course of the war and after the war, industry and the government got together and ironed out a lot of the problems of why doesn't this fit when you make one part, somebody else makes another part, and they all come together for assembly. So that caused a great amount of difficulty during the war, and after the war the economy was booming, so they realized that they had to do something. It was a tremendous cost to the industry and to the government because the government buys a lot of stuff, and the lead for this GD&T system was really the U.S. government, and particularly the military, since they buy so much stuff. And they evolved this GD&T system in conjunction with the automotive manufacturers, the aerospace manufacturers, to guarantee that everybody was following the same script. And this is what that script is. So what are those weaknesses? What we're going to step into in the very next video here is the key weakness of conventional dimensioning and tolerancing is there's a number of different ways that we can present the tolerances. The tolerances can be expressed in a note, they can be expressed in a standard, they can be expressed as a default table on the drawing, or they can be attached to specific dimensions. And even then, they can be expressed in a number of different ways. From blueprint reading, we talked about unilateral dimensioning, bilateral dimensioning, limit forms, all of those different ways of expressing really the same thing. There's a reason why we can do that. It is still useful to be able to do that, but you have to have some understanding of conventional dimensioning before we can really step off into GD&T. I do want to point out that the Y14.5 standard that hopefully you'll have in your hand soon is really part of an enormous series of standards controlled by ASME, also still some by the government, still some by other industry organizations. But just the Y14 series of standards covers a wide range of technical topics, especially related to drawings and how we produce them, how we maintain standards for different conventional pieces of equipment that you would see in the machine trades, gears, splines, springs, that sort of thing. All of these areas are covered and standardized in a publication by the ASME. Y14.5 is just one of those that deals with dimensioning and tolerancing as expressed on drawings. So GD&T is not a separate standard. It is just a more advanced way of expressing tolerances, and it's a very well proven system. It is proven over the years to be a very effective way to make sure that parts go together. And that's what we don't want to ever forget, is that all of this is geared towards successful manufacture. If we are not successful at manufacture, it costs companies money. And that is why they want their technical people to be trained in dimensioning and tolerancing, particularly GD&T. Okay, so I'm going to end this video at this point. There'll be another video where I'm focused a little bit more on the board, and we can talk about conventional dimensioning and tolerancing and point out some of the difficulties that GD&T is going to address.